Okay guys, we're going to look at target 1.2. And target 1.2 is I can use proportions I'm going to say I can use proportional sides and congruent angles to identify similar figures. So proportions, which we talked about yesterday, are going to be very important in a lot of the things we're going to do, because similar similar figures are proportional. Okay, so we'll kind of see how that works. So the first thing is, what is the definition of a similar figure? I gotta wait for the dot. Okay. Two figures are similar if their corresponding angles are congruent and their corresponding sides are proportional. So similar two figures are are similar if their corresponding angles are congruent and their corresponding sides are proportional. Okay, so let's see an example of that. This is going to be figure A, B, C, D. Right? And this is going to be figure W, X, it should be opposite. W, X, Y, Z. Okay? And I am saying that figure A, B, C, D is similar to W, X, I'll kind of talk about why did we have these pretty colors. Okay. But again, this one little squiggle means similar to. Okay, so A, B, C, D is similar to W, X, Y, Z. Okay, so the two things we have here is corresponding angles are congruent. Okay, just a little bit. So I want to look for my corresponding angles. So if I pick, I'm going to start with A. Okay. Well, what angle is the same as angle A? Well, angle A and like angle W are in the same place. So I would say angle A is congruent to angle W. And remember, this symbol and equals with a squiggle means congruent. Angle B, and I'm going to use two lovely little marks here and two marks there to show that angle B is congruent to angle X, right? So you can see why I did the colors, right? Those are the ones that are in the same spot. Angle C and angle Y go together. And my picture's not perfect. I apologize. And angle D is congruent to angle Z. Not me. Oops. I always put a line through my Z's. It differentiates them from 2's. Okay. Okay. So those are our corresponding angles. The other thing we have is corresponding sides. Corresponding sides are proportional. Okay. Oops. We also have corresponding sides that we have to deal with. Okay. The corresponding sides we get, so again, the sides are like the lines, right? So I'm going to go from this line here, and that line, we just call it AB. A lot of times they'll have numbers on them, but this example doesn't, right? AB, and remember, they're proportional, and a proportion is equal ratios or equal fractions. So I'm going to do a fraction over, well, what side does this go with? It's going to go with WX. So whatever the length of AB is, divided by whatever the length of WX is, should be equal to, right, my next one, BC over XY. which should be equal to CD over YZ, which should be equal to dA over ZW. Okay, so you're just creating fractions with the sides, and we'll see some examples of that. One thing to be careful with, though, is notice that I always put this triangle on top and this this shape on top and this shape on bottom. Okay, so they have to go in the same order. So if you do AB over WX, then you always have to start with this first one over here. If you switched it, then you'd have to switch all of them. Okay, so it's okay to switch it, but make sure if you switch it that you're actually switching all of them. All right, looking at our next example, or actually our first example, that's really just a definition there. I don't know what it's doing. What just happened? Cancel. Oh, I keep actually hitting something that's making it change to like typing it. Okay, example 1. If triangle FGH is similar to triangle JKL, and I draw our triangles over there. List all pairs of congruent angles and write a proportion that relates the corresponding sides. Okay, so there's my two triangles. And I have this lovely triangle. It's going to be F. And we're going to have this triangle, which is going to be J. Okay. All right. Okay, so the first thing we're going to do is list all pairs of congruent angles. So now we have to be careful when our triangles look like this, because as you can see, right, these don't look. Sorry, I'm accidentally highlighting things. What just happened? These don't like quite. Not they don't look similar. They are similar. It tells us that, but you can tell like this JKL here has been like flipped. Okay, like rotated. So sometimes you have to be very careful. The easiest way, and I know that angle F is going to go with angle J. Let me write that we're doing our corresponding angles here. What S is on this board? I'm going to say I know angle F is congruent to angle J. How do I know that? Right? One of the things you can do is use the names of the triangle. Names. The triangles. Okay? And what is the name of this triangle? Well, these are the names. Okay, so this triangle's name is triangle FGH. And this triangle's name is triangle JKL. And if you look here, F and J are in the same part. They're both the first letter in the name. So I can use that to tell me, oh, those are the angles that have to go together. And then I'm going to mark them. So F goes with J. My next one would be G and K. And again, just to differentiate, right, not only with color, but if you don't have color, right, that's why you do the multiple lines. So like G and K go together because they have 2 lines. F and J go together because they have 1 line. And then finally we have H and L, right? So angle H is congruent to angle L. So those will get 3 lines. Okay, we also want to write a proportion. Oops. We're supposed to be highlighting, not just writing every. Proportion that relates the corresponding sides. Let me move this down just a little bit. Okay, so same way, I'm going to use the names and kind of the markings we've already put on. So I'm going to start at F, which has 1 marking, and I'm going to go to G, which has 2 markings. So I'm going from red to blue. So that's F, G. So in my other triangle, I'm going to go from red to blue, J, K. And then just continue along, right? I'm going from blue to green, GH. And then I'm going from K to L, right? Or blue to green. And then our last one, green back to red, H, F. Over, again, green back to red, LJ. Okay. Okay, that's it for that problem. Last problem we're going to look at, example 2. To Determine whether the two triangles are similar. Alright, so I'm determining whether these two triangles that I'm going to draw are similar. So I have BAC, and B is going to be 27 degrees, and 17 degrees. 36 degrees. And our other one is going to look like this. And that's going to be J, F, and H. And this is 27 degrees. To 17 degrees. Okay, pretend there's a degree symbol there because I've tried 3 times now. Okay, so we want to determine if these two triangles are, oh wait, and we have side lengths. This is going to be 12, 8, 6, and this is 6, 4, 10. Oh my god. 3. Okay, so when we're determining triangles are similar, right, the first thing we have to do is our 3 angles. So I need to show that that 3 angles are congruent, or all, right, because a triangle has 3 angles. So really it would be, if it's any other figure, right, it's how many ever angles there are. So I guess all angles I'm going to put instead. We have to show right now that all the angles match. So like I start with angle B. It's 27 degrees. Well, I should be able to see that that goes with angle F. Because they're both 27 degrees. Okay. Our next one is 117. That one's also 117. So angle A is congruent to angle H. And then our last angle here is 36 degrees. Okay, and there is this 36 degree angle here. So angle C is congruent to angle J. Okay, so all of our angles do have like a matching pair. So we have to just do our sides, but being proportional, right? So this is where I write my fractions. So again, I follow the colors or the number of lines. So I'm going to go from B to A. And that side length, right, I'm not going to put BA, I'm just going to put 8. And then that was from red to blue, so red to blue is 4. And that should equal, I'm going to go from A to C, and that's 6. And then I'm going to go from blue to green, which is 3. And then finally we're going to go from C to B, which is 12. And then green to red, which is 6. So I'm saying I'm checking to see if all of these are equal. So I am just going to divide, right? It's the same thing we were doing yesterday when we were checking those proportions, right? Does 8/4 equal 6/3 equal 12/6? Well, 8 divided by 4 is 2, 6 divided by 3 is 2, and 12 divided by 6 is 2. Yes. All 3 of those are equal. Okay. Check. I usually put a check mark. If they're not all equal, I put like the not equal symbol. But okay, the last thing we have to do is actually state, right? It's asking us to determine whether the two triangles are similar. Showing all your work, we haven't answered the question yet. So this is very important. In a lot of these questions and like on tests, make sure you like end the problem. So I'm going to say yes, right? Everything seemed to work out. So yes, triangle. And I have to be very careful naming them. But if you did your angles, I'm just going to go in that order, right? So triangle B, A, C is similar to triangle, and then do the same order for my second triangle. So FHJ. Okay? And that is it. Have a wonderful rest of your day.